Hi everyone, this is David Collins from Arbor Guitars. Most of you are likely familiar with the old Gibson plastic bridges that they used in the 1960s. It was at a time they were just trying to get more instruments out to the masses. Unfortunately, we all know these came with a number of consequences, not only in tone but in the structural stability of the instrument. The tonal concerns are fairly obvious. Obviously, plastic is not the most efficient material for transferring energy to the top, and on top of that, the adjustable versions actually added a great deal of mass and impedance to the soundboard, in addition to another degree of separation between the strings and the soundboard. Perhaps even more importantly, however, is that the bridge really has to play an important structural role on the soundboard. The glue joint of a very stiff brace, essentially, does a good deal to keep the top stable, keep it from rolling and collapsing. And these 4 screws on a thin, flexible plastic bridge obviously just don't cut it for this purpose. So we find ourselves left with a conflict between preservation and restoration. Obviously our goals are typically to preserve as much of the original material and instrument as possible. However, in doing that and preserving a bridge like this, it can actually be a detriment to the long-term preservation of the instrument, as without the support of a properly glued hard bridge, the top can be prone to collapsing, the bridge can plow forward and damage the finish. All sorts of other issues can shorten the life of the guitar. So in cases like this, we have to make a choice on where to depart from strict preservation goals of original material in order to prolong the preservation of the instrument as a whole. The original plastic bridge, of course, was black. Rather than using ebony for the replacement, however, since we're not tied to preserving and mimicking original parts, since we are indeed modifying it, with consulting with the owner, we've chosen to go with rosewood on the case we're going to show you today to better work as a traditional match to the fretboard wood. We're also going to take a little liberty to redesign the styling of the bridge, since we're not intending to replicate an original part, we are indeed modifying it. We'd like to do it a little bit more elegantly. These original bridges were really kind of shapeless, no lines to demonstrate intentional craftsmanship, just really a big shapeless blob laid down on the top. We're going to refine it and take some cues from some of the more traditional Gibson styles, as well as others that we feel look most appropriate for the instrument. So with the bridge removed, our first step is to plug all of the holes that were drilled through the top, and there are a lot of them. In order to do this, we turn down custom tight-fit spruce plugs with the grain orientation the same as the top. This is done with future service and preservation in mind. If you were to glue in cross-grain dowels, this could severely impede any work done on the bridge plate in the future. These spruce plugs will shear quite neatly across the grain should the bridge plate ever have to be removed at any point down the road. We'll even do our best to minimize invasiveness to the top by turning stepped plugs to tightly fit into the 2 stepped holes so that we don't have to remove any more material than necessary. And then with the spruce plugs trimmed on both the inside and the outside, it's time to measure the neck angle and figure out what height bridge we're going to need for this job. And now it's time to make the bridge. We'll start with a piece of rosewood reasonably well matched to the fretboard, create a few reference planes on the block, and begin to measure and drill out our bridge pin holes. Once the holes are drilled, we'll start to shape the rest of the bridge. We start by radiusing the bottom, then we clean up the perimeter and begin to shape and radius the top and the wings. Once the bridge is rough shaped, we'll take it back to our bench and finish it up with traditional files, hand scrapers, and finally a bit of sandpaper to polish it out before taking it to the buffing wheel. Our next step is to return to the guitar and begin to prep the top to fit the new bridge. Once this is completed, we will actually cut a very small rabbet around the perimeter of the bridge, only to the thickness of the finish, and set in about 50 thousandths from the edge. This allows us to achieve a solid wood-to-wood glue joint without cutting the finish all the way to the perimeter of the bridge, where these old finishes can be easily compromised. It also provides for a good lock to keep the bridge in place during the gluing process. Now, because we choose to use traditional hot hide glue for this job, it's important to set up and prepare our clamping arrangement so that we can minimize clamping time during the gluing process once the glue is applied. With this prepared and the bridge and the top pre-warmed, we will do a final scraping to clean up our bridge gluing surface, wet both surfaces with hot hide glue, and in under 30 seconds are able to install the bridge and fully engage the clamp. After allowing the hide glue just a few minutes to begin to gel, cleanup is quite simple. Now with the bridge installed, it's time for us to take a closer look at the bridge plate. With the prior damage to the plate surface, in addition to all the soft spruce plugs, we are going to have to put a thin maple cap on there, about 60 thousandths, and only as large as we need to cover all of the previous holes. And again, preparing your clamping arrangement using well-designed cauls with good locating systems can make the job a whole lot easier when you're working with the short open time of traditional hot hide glue. Now our next step is to measure out the scale length on the individual instrument and then mark the saddle position with appropriate compensation. And now with our saddle slotting mill, we can very easily cut a perfectly clean and located slot to ensure a good fit and ideal intonation for the individual instrument. Now we drill out the bridge pin holes through the top and the new plate cover. Then we will ream out to rough fit the pins, chamfer the surface, followed up by a final fitting of the bridge pins. Now it's time to notch, file, and ramp the slots for the solid bridge pins we choose to use. Then after a final bit of cleanup, a new bone saddle, and a setup, we have a bridge that looks better, an instrument that sounds better, and most importantly will be structurally prepared to last for generations to come.